video explains the basics of integration, with a focus on basic algebraic integration. It's important to understand for integration that differentiation and integration are linked. With differentiation, we differentiate a function to get to the derivative. We can think of integration as bringing us on the reverse of that journey from the derivative back to the function. That's not all that integration will do, but it's what we'll start with. Let's start out with the function y equals 6x squared plus 4x plus 2. And let's first of all look at its derivative. Now this is an easy function to differentiate. It's going to give us 12x plus 4. Let's look at a second function. This looks really like the first function. 6x squared plus 4x plus 3. What would this differentiate to give me? Well, the derivative this time would also be 12x plus 4. Let's really hammer the point home. Here's a third function. What's its derivative? Yet again, the derivative is 12x plus 4. So all three of these functions differentiate to give me the same result. Now let's reverse the process. I have my derivative and I want to get back to my function. To indicate that I want to take this expression and integrate it, I'll use my integration symbol. And notice that I have a dx at the end of the expression. That's just to indicate that I want to integrate with respect to x, that x is the variable that I'm interested in. Now we know at looking at the differentiation side of the page here, that if I integrate 12x plus 4, I'm going to get 6x squared plus 4x. That seems pretty certain. But I don't have a way of figuring out what number I should put at the end. When I integrate this, I could end up back at any of these original functions. To cover all those possibilities, I write down plus c. We call this plus c the constant of integration, and it's really, really important that you include it when you integrate. Now for this particular integration, it was really easy for us to know what the result should be because we had all these workings out here on the left showing us what function we came from to get to the derivative of 12x plus 4. So we were easily able to reverse. But what happens if we don't have this information, if we're just given an expression and we want to integrate it straight out? Is there a rule I can use for integration? Well, there is, and it says that if I integrate a term x to a power dx, that the result will be x to the n plus 1 over n plus 1. So I'm upping my power and dividing by the result. And this is the exact opposite of what we did in differentiation, where we reduced the power and multiplied by the original power. The only thing they haven't included here is the plus c, the constant of integration. And if you go to page 26 in your log tables, which is the page for integrals, they'll give you this rule, but they won't include the plus c, so you have to remember that yourself. So let's have a look at an example. So here I have to integrate x squared plus 4x plus 3 dx. Often you'll see a bracket around the expression just to indicate that it's all being integrated dx. So to get my result, I'll take each individual term and follow this rule. So I'm going to first of all say x squared. Well, I need to raise the power by 1 and then divide by the result. That's going to give me x cubed over 3. Next, I have to do it for plus 4x. Now bear in mind that's 4x to the power of 1 at the moment, although we won't tend to have that 1 written in. So again, we'll up our power and divide by the result. Next, I've got this 3. Now this 3 at the moment doesn't have an x. So effectively what I'm going to do is reinstate the x. If you think about it, this has 0 x's, so I'm increasing that by 1, just like the plus 1 up here. And this is now 3x to the power of 1, but we don't tend to write it in. And again, you could put it over 1 if you wanted to, but again, we don't tend to write this in. I'm nearly there. I have integrated each of the individual terms, but I mustn't forget my constant of integration, my plus c at the end. If I don't have this, my answer isn't completely correct. And I can tidy up a little bit if I like, to get x cubed plus 2x squared plus 3x plus c. Okay, let's look at a second example. So this time I want to integrate 4x cubed plus 1 over x squared plus root x dx. Now, just like in differentiation, I'm not really keen on trying to integrate when there is an x term below the line or when I've got a root involved. I'd much rather sort these out in terms of indices before I begin. And so my first step won't be to integrate, it'll just be to rewrite this expression. Notice that I'm starting off by writing down my integration symbol, and this just indicates that I haven't integrated yet. I'm still waiting to use that. So 4x cubed is fine as it is. Plus 1 over x squared, I'm not liking it looking like that, so I'm going to change that. How do you think it'll look? So I'm going to say plus 1x to the minus 2. And then finally I got this root x. Again, not liking it written as a root. I want to write it using indices. How would that look? That's going to be x to the power of a half. And now I can begin to integrate. And I'll use the exact same rules before. So I'm going to up the power and divide by the result each time. So first of all, 4x cubed. What's that going to look like when I integrate? It's going to be 4x to the power of 4 over 4. Take care in the next one. I want to increase minus 2 by 1. So where am I going to end up? When I increase minus 2 by 1, I end up at minus 1. I'm going to the right on the number line. And then finally, I've got x to the power of a half. And that's going to give me x to the power of 3 over 2, all over 3 over 2. I'm not quite done yet for a number of reasons. The main thing is that I haven't written in my plus c. So that's done now. And I do have the option of simplifying my result. So if I simplify, what will I get? Well, the first term, the 4's are going to cancel off, leaving just x to the power of 4. I resolve the next term using indices, minus 1 over x. And for the last term, I'm dividing by a fraction, so I can flip that and multiply. And then the x to the power of 3 over 2, well, don't forget, the top of the power is just a regular power, and the bottom of the power is a root. So I'm going to square root the x and cube it, and make sure to write my plus c on the end. It's very important to note that integration does not use product, quotient, or chain rule, so that if I'm presented with a question where there's division, or multiplication, or powers, that I need to simplify my expression before I begin to integrate. For example, with this question, I'd have to expand the brackets first of all, before I go anywhere near integrating the question. Pause the video here, multiply your brackets out, integrate, and then play and see if you got the same result as me. So after multiplication, this is what I got, 4x cubed minus 1x squared plus 12x minus 3 dx. And on integrating, I have 4x to the 4 over 4 minus 1x cubed over 3 plus 12x squared over 2 minus 3x plus c. And again, I can simplify this. So my final answer can read x to the 4 minus 1x cubed over 3 plus 6x squared minus 3x plus c.